Assalamualaikum warahmatullahi wabarakatuh. So this video is on the chapter 7. Chapter 7 is about cost estimation and economics. Okay, so as per introductions, most chemical engineering design project carried out to provide information from estimation of capital and operating costs. And normally engineer must be able to make rough cost estimate to decide between project alternative and also to optimize the design. Okay, so when you're dealing with the process equipment design, you also need to consider about their costing to develop the chemical plant. Okay, so first thing you need to know is the capital cost. So what is a capital cost? This capital cost is fixed cost. Normally, it is a one-time expenses incurred on the purchase of land, buildings, construction, equipment that being used for the production of goods. Good is a product or in the rendering of the services. So the total cost needed to bring a project. Normally this capital cost is the total cost needed to bring a project to a commercially operable status. Okay, so the capital cost can be estimated by classified this capital cost into 3 types. So for the first type is preliminary and authorizations, and lastly is detail. So for the preliminary, usually we use the information on the initial feasibility study. We need to make a cost choices between design alternative. So basically for the preliminary, the cost accuracy is around 30% only. So basically in preliminary, we will do a rough estimations. So for the authorization also known as a budgeting. So this authorization of fund to proceed with the design. So at this part, we need to start to do a budgeting. So this budgeting, normally the accuracy is around 10 to 15%. We can see that the estimation is more tighter as compared to the preliminary. So the last one is detail. So the detail one, basically we already asking for the quotation from the vendor. So for project cost control and estimate for fixed price contracts, that's mean we already request for the contracts, and we also we also completed the process design, the equipment that need to be used, so we can get the quotation for the equipment and construction for the cost estimation. So the accuracy for this detail capital cost is around 5 to 10%. Okay, so next is fixed capital. So what is fixed capital? Fixed capital is one of the investment. So it is the total cost of designing, constructing, and installing a plant, and the associated modification needed to prepare the plant site. So this fixed capital is invested in fixed asset. So basically, this asset will be permanently stay inside the business. So what we can include for the fixed capital is all item of equipment and their installation, all piping, instrumentation and control system, building and structures, auxiliary facilities such as utilities, land, building, and etc. Okay. So the other type of cost is working capital. So this working capital is the additional money needed above what it costs to build up the plant. In order to start up the plant and run it, before we start to earning income, we need to have the raw material, intermediate inventory, credit for account payable, fixed stock, solvent, catalyst, packing, spare part inventory. So all of this inventory is a additional money that we need to allocate. So this one is being used to make sure the plan can be start up. So the total investment needed for a project is a sum of the fixed capital and also working capital. Okay, so next is estimating purchase equipment cost. So we have 3 ways to estimate the purchase equipment cost. First is vendor quotation. Next is previous cost on similar equipment and scale for time and size. That means based on the previous equipment that been used inside the other company. So that equipment on 2003, let's say, the cost is 500. So we use that equipment cost as a basis, and we do a scale up for the time and size for our equipment. Okay, next is use cost estimating charts and scale for time. So as compare for 3 method, the vendor quotation is most accurate because it based on the specific info and also it requires significant engineering. That means we already have a completed design. From the completed design, the vendor give a quotation. That one is most accurate. So for the second one, the accuracy is reasonably accurate, but we need to beware of large extrapolation and foreign currency because we dealing with the scale, the indexes for costs. So that's why we need to do a forecast or extrapolation in order to know our current costs. Okay, lastly is use cost estimating chart and scale for time. So this one also is seem like the second method, but the second method is specific on the size. But for the third method, we only use the charts and also for the time in order to know the current cost of the equipment. This one is less accurate, but it is convenient. Okay, so this is the second method, which is effect of size. The first method I didn't show inside here because that one is a straightforward method. You already get the design and you asking for the vendor to give a quotation. So from the quotation you can get the cost. But normally inside the plan design we didn't do the method one because we don't have any completed design and we don't have a confirmed design to request for the quotations. So this one is referring to step 2, effect of size. Okay, basically we have CA is a cost estimation, cost that we need to estimate. CB is the previous cost for that equipment. AA is a size of equipment that we want to calculate to estimate the cost. Size of our equipment. So AB is a size of previous equipment. Okay, in the next slide I will show the example on how to calculate this cost of estimation. Okay, so basically we need to know the CA lah. Okay, just now we have exponential n right inside the formula. So that n basically is normally the range is around 0.4 until 0.8. Oftenly we will use 0.6 lah. Okay, so inside your calculations you need to assume n is equal to 0.6. Okay, so this is example 1. So a new plant ordered a set of floating head heat exchanger. This one is a heat exchanger. So the area for heat exchanger is 100 meters square. the cost is 92,000. So what would be the cost for a heat exchanger of similar material if the area reduced to 50? The N is 0.44. So we can use the formula of CA just now to calculate to estimate the new cost for the heat exchanger with the size of 50. So using the formula from the previous slide, CA over CB equal to AA over AB to the power of N. Okay, CA, the one that we want to know, CB is 92,000. So AA is the equipment that we need to estimate the cost, which is 50. AB is the previous equipment that cost around 92,000. So we just input the information and we calculate that CA would be 67,300. So this cost is estimated for 50 meter square heat exchanger. Okay. So just now we already discussed on the effect of size. Now we will go to effect of time. So this is the third method in estimate the cost of equipment. So as the time increases, the cost of the equipment will be increases is due to the inflation. So inflation is measured by cost indexes, which is we have currently been used is Chemical Engineering Plant Cost Index, CAPC, and also Marshall and Swift Process Industry Index. Okay, these two is the commonly used index currently, but we have the other type of indexes that can be used. Okay, so the equation for the time effect, we have C2 is equal to C1 over I2 over times with I2 over I1. So C2 is the new cost. This is the previous cost from the previous year. I2 is a index for the current year. This is for the previous year. Okay, so this is the type of index that available. Okay, we have the other type is Nelson Ferrer Refinery Construction Index. So basically we have 3. So every year the index is changing and increases from year to year. So we can see here on 1990 the index for the Marshall is around 350. It increases until up to 500 on 2005. So these indexes we will use to estimate the cost of equipment. Okay, example 2, cost of vessel in 1993 is 25,000. What is the estimated cost in 2007? You need to use the CE index, the Chemical Engineering Index. So the CE index given that the estimated cost in 2007 is 500. Okay, so we use the formula C now is equal to C for the previous year times with I now over I for the previous year, which is 1993. Okay, so given in the question is the C for 1993, which is 25,000. The current index on 2007, 500. So from the graph just now, from the graph of indexes, we can see that on 1993, you may refer to the previous graph just now. The value of index is around 359. So okay, from this information we can calculate the current cost, which is 38,820. So you may use these two approach, either the approach 2 or approach 3 to calculate the estimation cost for your equipment. But okay, for the approach 3, you may use either the 3 indexes available. So depends on you. If the index that you have is around, if the index graph provided is until 2005, you need to do the extrapolation in order to know the current index. So to estimate the future cost of a plant, some prediction has to be made of the future annual rate of inflation. Inflation is difficult to forecast, and the allowances for inflation is often included in the contingency charges added to the project cost. Okay, so now we move to example 3. So this one is also a time effect index, the step 3 method to calculate the equipment cost. So the purchase cost of shell and tube heat exchanger is around, for the carbon shell 316 stainless steel tubes with the heat transfer area 500 meters square was 64,000 in January 2003. Estimate the cost in January 2008. So use the MS equipment cost index. Okay, so let's have a look on how to solve this question. Okay, so this is the graph that I'm referring to. So you may find the index. Just now we have 2008 and also 2005, right? 2003 and 2005, we have the indexes inside the figure. So from the figure, okay, by looking at the figure, for the chemical engineering indexes, we obtain that the index is 1123.6 for 2003, 1244.5 for 2005. So by the extrapolation from the period 2003 to 2005, the MX index for 2008 would be 1426. Sorry, this one basically is referring to MS index. Okay, try to look to the graph and see whether you can get this value, the same value or not. Okay, like what I'm saying before, the period, the graph only shown to you until 2005, right? So in order to know for the 2008, you may do the extrapolation in order to know the index on 2008. So after do the extrapolation, we'll obtain 1426. Okay, so the estimated cost in January 2008, okay, you can calculate. So this is the cost, the index for 2008, the index for 2003. So the estimation cost is 81,000. Okay, so now we move to economic evaluation. So basically, on the economic evaluation, I will cover on the cash flow and cash flow diagram. So during any project, cash initially flow out of the company to pay for the cost of engineering, equipment procurement, and plant construction. That means we will use up all the cash. We will credit out the cash. Once the plant is constructed and begins operation, then the revenues from sale of product begin to flow into the company. So at this time, the cash start to credit inside your company. Just now we just credit out all the cash because we want to pay on the engineering, equipment, plant construction. When the when the product start to sell, we start to get the cash. So the output are goods for sales. That means the product that been sales, and cash return are recycled to the organization from the profit earned. So the net cash flow at any time is the difference between the earning and expenditure. Okay, so this is the graph of cash flow diagram. So we can see there is a 6 point here. So from point A to B, despite the investment required to design the plant. So this is the stage whereby we start to design the plant. So B to C is the heavy flow of capital to build up the plant and provide fund for startup, including working capital. So from B to C, we will use the cash for the fixed capital, which is on construction, installing equipment, and then we also need to start to use to buy a working capital like raw material, services. Okay, from C to D, basically we start to earn the cash for our company. So basically, from C to D, the income start being generated from sales. So the net cash flow is now positive, but the cumulative amount remain negative. Still, the cumulative still negative. So this is the axis. The bottom one here is negative side. This one is positive side. So from C to D, A, B, C, D still in the negative side. But at the point CD, we start to earn the money. So why the cumulative amount remain negative? Because the investment is paid off. That means we need to pay the investment first before we start to earn the profit. So from point D to E, which is D to E, in this region, the cumulative cash flow is positive. So the project that you've been working for is earning a return on investment. So ROI lah. From D to E start to gain the ROI. So E to F is toward the end of the project life. The rate of cash flow may tend to fall off. So this one we can see this slow progress, slow increment of the cash flow because at this time the project is toward to the end of the life. So the cash flow sometimes can tend to fall due to the increased operating costs, falling sales volume, price due to obsolescence of the plant, the slope of the curve changes. That means maybe by that time the volume of the product sales slightly decrease, and the equipment start to damage or need to do a full maintenance. So that's that all of that require cost. So that's why increase operating costs. Okay. So next, on the economic evaluations, we need to perform the simple method for economic analysis. So first analysis is payback time. So a simple method for estimating the payback time is to divide the total initial capital, which is fixed capital plus working capital, by the average annual cash flow. Okay, so basically you divided the total of this one with the average annual cash flow, then you will know the payback time. So this one you need to calculate inside your assessment 7. So okay, payback time, this is not the same payback time indicated by the cash flow diagram, as it assumes that all the investment is made in year 0 and revenue begin immediately. For most chemical plant project, this is not realistic, as investment are typically spread over 1 to 3 years. and revenue may not reach 100% of the design basis until the second year of operation. So for the simple payback time, they neglect the taxes and depreciations. So when you calculate the payback time, then you need to make sure that you get the value, the range of your payback time is around 3 to 5 years normally, because during 1 to 3 years normally the investment are typically spread over. So after all the investment paid off, then you will start to have a payback time. Okay, so next is return on investment, which is ROI. So we have two methods to calculate the ROI. The first one, you can use net annual profit over total investment and then time with 100%. If ROI is calculated as an average over the whole project, then you can use this formula, which is cumulative net profit over planned life time with initial investment time 100%. Okay, this ROI also can be calculated based on the figure of the cash flow diagram. Okay, you can see here, okay, from figure, the cumulative net profit is happen from C to F. So you may obtain the value of the cumulative cash flow F at point F and at point C, and then you minus F with C, to get the cumulative net profit, and then you divide it by planned life. So this one is investment, which is C, the planned life is G, the initial investment is C. So the C value, you can get this value at this point. For the life of the project, from this one, okay, you get the planned life. So you may solve the ROI for your company, okay, by minus F with C over C times G time with 100%. So you will obtain your ROI. Okay, so this is the end of chapter 7. So make sure inside your assessment 6, you need to cover all the content that been highlighted inside this chapter. Okay, you may come up with you may find the information inside the internet in order to find the index and in order to estimate the cost of equipment. Okay, I think that's all for this chapter 7. Thank you.